Okay, let's talk about a very interesting blog post. This is not an RFC, but it's written by some members of the foundation, so it's gonna be cool, I guess. I haven't read through this. My colleague Roman, who is like helping out with the foundation, told me, Brent, you need to look at this. It's been posted on Reddit. So many people are upvoting it, but I have no clue what it is about. So let's take a look, shall we? The state of generics and collections in PHP, I guess. So generics have been on the list of wanted features for a long time by numerous PHP developers, me included. And the topic is often brought up in What's New in PHP talks, as well as during Q&As. In this article, we will be exploring the different approaches and what their current state is. This is so cool. I've written about generics like so many times. Like before going into this, let me quickly share my point of view. It can be like summarized in one sentence. This one, we do not need runtime type checks. That's basically it. If we get rid of runtime type checks, optionally, of course, we can add generics and things will be great. So there's a lot more to say about that, but let's first read through the blog post. So, full reified generics. With generics, you can define classes with placeholders for the types of their properties and methods. These can then be specified when instances of the class are created. This enables code reusability and type safety across different data types. Reified generics are implementations where the generic type information is defined and carried through to runtime. So, generic type information at runtime, allowing for runtime enforcement of generic requirements. And so, it's not necessarily about syntax here, because as far as I know, generics, whatever kind of approach we would take, they will look the same, but it's about when types are checked, right? And reified generics, they are checked at runtime. The generic type information is available at runtime. And, it's how PHP does it, right? That's how the PHP's type system works. But there is, of course, a problem. Maybe, let's see here, we have an entry with a key type, value type. Hey, this is interesting. This is actually something I was talking about on stream or in a video a couple of weeks ago, no? Like an array entry that has a key and a value. Pretty cool. So you define over here, you create a new entry. You say this specific entry has the key of integer and type of blog post. And whenever you do get key and get value, the return type will be the generic return type. Okay. In the instantiated class, the generic type key type will be replaced with int, and each instance of value type with blog post, resulting in an object having like the following class definition. Yeah, so int and blog post here. And this is happening at runtime, right? That's reified generics. There have been a few attempts in the past to add this functionality to PHP as well. Nikita Popov attempted the most comprehensive experimental implementation in the 2020, 2021, following up on a draft RFC from 2016 and a Reddit post summarizing the remaining challenges. This is, this was from the AMA we did with PHP Storm a while ago. Yeah. Oh yeah, I was asking some questions here as well to Nikita. By the way, like this RFC here, I've written a lot of content about it. Like I did a whole series about generics on this channel as well. I think they were the first videos. Look at that. Yeah, that's like the very first, one of the first videos I did. Hello. So yeah, if you wanna check it out, I'll leave some links in the description to the video series as well as the blog post series if you prefer that. And I explained probably a couple of things that are gonna be mentioned in the blog post as well. So at the start of this year, under the auspices of the PHP Foundation, what does auspices mean? Like a divine or prophetic token? I still don't know what it means. Anyway, The PHP Foundation. Arno restarted this effort using Nikita's work as a starting point. Although many technical issues have been addressed, plenty of them are still unresolved. A key challenge is type inference. The use of generics tends to increase code verbosity because it requires type arguments to be specified each time a generic type is referenced. This is demonstrated in the following snippet. Yeah, so if you have a function f here, it takes a list which has a generic type. It requires entry with int and block post. So basically an array, a list implementation where the keys are integers and the values are block post. Honestly, this is like, in my opinion, entry shouldn't be here at all. It should be just list int block post without the entry in between. So yeah, and it will return a map of int block post, and then yeah, this is where the type inference is problematic. So you return the return type here, it makes sense to define a generic type, but over here, new map, and then you say int block post entries. It's kind of annoying, right? Having to write all of this every time you want to instantiate a new map. And let's take a look here, a list of block ideas. Yeah, okay, so just map, blah, 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 return map, and then a lot of generic types. Yeah, this becomes verbose. So not necessarily in the class, in the method definitions, it doesn't really matter. Well, it's actually important to have generic information there, but having to rewrite all of this every time, yeah, that kind of gets annoying. Type inference can reduce this verbosity by letting the compiler deduce the appropriate types automatically for us. For instance, in the examples above, the compiler might automatically determine the correct types for new map and map. However, this is hard in PHP. Quoting Nikita, primarily due to the very limited view of the code base the PHP compiler has. It only sees one file at a time. Yeah, that is kind of a problem. This is, PHP is an interpreted language, right? You write some code and it's compiled on the fly and executed right then and there. This is something entirely different than like a programming language with a dedicated compile step and a static analyzer built into that compile step. It has a static analyzer has the view from the whole code base. And actually PHP has static analyzers, right? There's PHP Stand, there's Psalm, PHP Storm, if we're talking about real-time static analysis. So there are tools that see the code base as a whole. The problem here is that the PHP runtime has no idea. And there are good reasons for that. Performance, probably, right? So, yeah, this is like a big problem with generics. Consider the following example. We have a box with a generic type of T. So, and then we pass that into the constructor. Yeah, over here. So box, you instantiate new box get value. In this scenario, the type of the get value expression is unknown until the function is loaded at runtime, making it impossible to infer T in the new box during compilation. So get value has a return type, which could in theory be used to set this generic type, because see, we're passing in here, we're passing in an object, an object with a generic type, and that type should be used to then determine the generic type of the class. Well, that doesn't work in PHP at runtime because we don't know the return type, the concrete return type of get value here at runtime. Well, during compilation, but like for PHP, at runtime is first the compilation step and then the execution step, right? Now we could assign T at runtime based on the return value of the function, but this would result in unstable typing. In the previous example, the type of new box would depend on the implementation of the return value of get value, which may be too specific. Combine that with the fact that box is invariant, and this code would break very quickly when trying to do anything useful with the box instance. Let's see here. We need box. This function requires a box with a generic type that implements value interface, right? So over here we have at runtime we have box A, but statically we don't know, so we call do something with box, and it accepts box value interface, but not box A, right? Okay. Because, well, A implements value interface. I'm not sure what they mean with this example, but you can guess that like there's information missing for PHP, and it's going to make things very hard. Typing is most useful when it's based on compile time static information that doesn't depend on the implementation. And this is key here. This is the key. This is what I've been saying for years now. Like, we don't need runtime type checks. It's not necessary. Like this blog post here, let me read this paragraph. But do you want to make a guess when I last encountered a type error in one of my projects? I can't remember, so it's probably a few years, and this blog post is 3 years old. So coincidentally, I started relying on static analysis around the same time. Like, if you have a static analyzer, you don't need runtime type checks. You do not need them. The problem is there is no built-in static analyzer for PHP, and well, there are a couple of external tools, but you can imagine how it's a pretty like debated topic, right? Note, in this example, box is invariant as it is often the case of generic classes. This means that box X is neither a subtype of or a supertype of box Y, regardless of the relation between X and Y. So box A is not a subtype. Oh, that's what they're saying. Box A is not a subtype of box value interface, and do something cannot accept box A. Yeah, isn't that a bit weird? I don't know. No, I get it. So they are talking about the static types. So the return type of get value should be box value interface instead of box A, and then it works. I actually think if we look at static analysis today, this would work as well, like with PHP Stan or PHP Storm. A generic class is invariant when one of its type placeholders is used both in read and write positions at the same time. A property type is both in read and write position. Yeah, sure. Okay, to understand why, consider the following example. So they're going to explain the invariant part, right? The change value function accepts a box value interface, thus should be able to assign any subtype of value interface to box value, right? However, if we pass a box A with the A subtype of value interface, this contract breaks when we assign a value that is a subtype of value interface, but not A. Sure, yeah. The common solution in other languages is to allow a type parameter to be marked variant in only one direction, typically in or out, provided it is used only in parameter or return positions, respectively. That allows that type parameter to be contravariant or covariant as appropriate. Sure. So it feels like we've diverged a little bit from like the original problem we were talking about here with type inference, but let's continue. To address these challenges, we explored a hybrid approach that lets us implement static inference of generic parameters without having the full information available at compile time. This approach represents unknown types as symbols at compile time. So the type of the expression get value is represented as fcall get value, right? Symbolic types can be resolved at runtime when needed after functions and classes have been loaded at a fraction of the cost of running the entire analysis at runtime. This operation can be cached for the duration of the request and maybe in caches similar to the inheritance cache. A proof of concept was implemented and used to implement data flow-based local unidirectional type inference of generic type parameters with the same behavior as PHP Stan and Psalm. The approach works and could be used to experiment with other flavors of type inference. It's all cool, but I'm still not convinced that this is the right approach because, like I said, we don't need runtime type checks. We need a way to opt out of it, is what I mean. But yeah. Performance considerations. Another concern with generics, right, is their impact on performance. Preliminary, I can't say that word, but benchmarks indicated that generics do not affect performance of non-generic code. That's good. Simple generic code shows a modest performance degradation of about 1 to 2%. Right. However, later exploration has shown that compound types, such as unions, can lead to superlinear time complexity in type checking, potentially resulting in more substantial performance drawbacks. For example, checking whether AB accepts B is linear, but checking box AB against box AB is O and M. Superlinear complexity is also reached when merging compound types during the resolution of symbolic types. Like, okay, there are some performance issues, and it doesn't look like the blog post is going further into it. I feel like the blog post, this blog post should have focused a little bit more on making things more clear to normal PHP developers, because it's on the foundation blog, and I would say that this blog post could be used as a way to promote the foundation. This is what we're working on. Like I said, I don't know where it's going, but this is what we're working on, and yeah, we want to invest some time in it. Please sponsor the foundation. Please do that. Yeah, it's like it's super technical already. Like, I can follow along most of the things here, but yeah, I know from experience, I've been reading about this for years now. If you're not like making your own type system, it's very difficult to understand all of this. And I'm pretty sure that many people here in the video will also feel the same way. Like, not really sure. Anyway, that's just a side note, but just a general feeling I have when reading this post. Future direction. Ongoing challenges for reified generics include evaluating the effects of compound types and extreme cases. Sure, implement type checking inline caches and research more sophisticated algorithms for checking compound types. And explore eager loading, automatic preloading, that's nice, or inheritance cache alike to reduce the amount of symbolic types. Sure, so there are some problems here, right? Collections. One of the main use cases for generics that is often gets brought up is the need for typed arrays. But I want to interject here. Like, I've been doing a lot of work on Tempest now. Let me actually get PHP Storm here. Okay, so we use quite a lot of generic types in Tempest, and the thing is, it's only rarely used for collections, to be honest. I'm not saying it's not used for collections, but the biggest part is, for other use cases. Let me get an example here. The object factory, for example. This is an API to map data from one source to another. And let's see here for class. Let's see an example here. Okay, so we have make query from a model in this case. So make a query from this model instance. You want to know that the return type here is an instance of query class. This is where generics are very, very useful, because if you look here, we define and this is something that doesn't exist in PHP, but a class string with a certain type. And then we say return an object factory with the generic type of that class string. So those are actually like more often the use cases I find for generic. Let's see whether there's another example here. Again, class string and reflectors, right? You pass in some information that represents a class, and you want to return. Let me see T. Actually, I actually don't remember how all of this works just by glance, but it doesn't really matter. For the container here, we pass in a class name and we return the instance of the class name, Stuff like that. That's what generics are most useful for in most of the code I'm working with, at least. So I have a suspicion that this blog post is going towards, generics in general are gonna get difficult, but we maybe can add typed collections, which isn't a bad thing, but it's not really what what we're using generics for, I feel. So I don't really agree with this statement. One of the main use cases for generic that often, well, yeah, I agree with it. It often gets brought up, but there are so many more use cases for it. So yeah, in PHP, the Swiss Army knife array type can be used and abused for lots of reasons, but you can't currently enforce the types to be used as key or value, right? In a parallel project, we have been working on a dedicated collections syntax as a less challenging alternative to full generics. Yeah, this is what I was fearing for, actually. Collections would come in 3 flavors: sets, sequences, and dictionaries. Sets and sequences only define a value type, whereas dictionaries have key and value types. The syntax of these could be as follows. Let's see here, we have an article, and then we have, oh yeah, and then you create. No, I don't know what this does. I honestly don't know. Collection, is that a function? It's probably a keyword. We say sequence, and then this is the type. Articles. Yeah, collection dictionary. Hang on a second. Sets, sequences, and dictionaries. Sets and sequences only define a value type. So this is the value type. Okay, so I think I know what this means. Hang on. Let's okay, so this means we'll have a articles collection, right? So articles equals new articles, like this, and it can only accept new article instances, right? Maybe like this, maybe like so, I don't know what that would look like. So, and then here, this is such a weird syntax, man. And then over here, it's basically the same. So we have yearbooks equals new yearbooks, and then it requires ints, new book, something like this. Not sure. Okay, so I think that's what that is about. Sure. Oh, it's actually, you can instantiate these sequences and collections like you would do with any normal class. Yeah, okay, this is cool, but it's also not solving, I feel like, the main use case. And that's something like this. So function get books, this is what we need. If we're talking about collections, we need to, we don't need to define it over here. Like, because if you're doing this, if you have to manually define a collection, then we're not getting any improvements here, really, because you could also do like class yearbooks extends, I think, array aggregate, I don't know, iterator aggregate, no, array iterator, I don't know, some of these classes, right? And you could add some kind of docblock here, method get, or no, I don't remember. You could probably, let's actually check here. Array iterator, you need to pass in the array, and then offset get, you need to define the return type. So if you say offset get and define yearbook over here, and then say return parent offset get int e, something like this. I don't know. Let's double check it. Just key. So like this. Okay. So if you do this, you already have static analysis on a loop of these objects, basically. So this isn't really much better than this. Okay, it's 2 lines less code, but still, it's not something you can just plug in, and that's the big benefit of generics, right? You can just create your types here, and you know, this is special syntax here because it could be something like this, but still. And this is something that PHP Stan, for example, actually has support for. Anyway, in the example above, well, hang on a second. Sequences and dictionaries will automatically have many methods defined on them. Okay, that's good. Providing a base functionality like PHP has with the array functions, that's good. If you use the defined methods to add or update elements in the collections, then the type for the keys and values have to match the ones as defined on the collection. Yeah, I get that. In the example above, the add method for the yearbook's dictionary then requires int to be used as key and book as value. For the main manipulation methods, array access style overload operations will also work, as well as potentially operator overloads. One of the drawbacks of collections is that you need to declare them. That's what I was saying, yeah. Following adopted practice, that would mean a single line declaration in a separate file for each collection. Another concern is potentially higher memory usage. As for each class, PHP will have to keep a corresponding class entry, including a list of all the associated methods. And a third concern is that there is no instance of its relation between collections and compatible type. Yeah, you cannot. Yeah, check here. So why is the syntax different now? Is collection sequence or just sequence as A's and B's? So yeah, okay, let's continue to read. Collections, although less powerful, can be an alternative to generics in many use cases, but without much of the complexity. But I don't really agree with this. Like I've shown before, and I'm pretty sure. Maybe we could open the. Let's see here, RFC vote, like the Laravel code base. This isn't what generics are used for. Like, yeah, they are used for collection types, but not. They aren't like the majority of use cases. Let's see here, Laravel. Where's Laravel? Over here. Let's see. Let's do a search for template here. So maybe do it a bit like this. Factories, repositories, like these aren't collections. These are in the array class, and then there's the collection. Of course, it uses a lot of generics here. But let's check enumerable, for example. What is that used for? Okay, so this is for arrays as well. Like, I'm not saying it's not used for arrays. Lazy collections, enumerate values, conditionable. This is interesting, right? So when, yeah, it's gonna be difficult to explain this, but okay, let's just say here's an example, a good example of the conditionable trait here. You pass it something, and then let's see. It infers the return type of the closure, and it will use that. Oh yeah, over here. Over here. It infers the return type of the closure, and then it will return actually what the closure returns. Yeah, I don't remember exactly what this function does, but you see, those are the things that are like super useful if you have generics available. Anyway. Larry Garfield has conducted research in other languages and how expensive their collection APIs are. It's still in rough form, but the consensus seems to be include everything, possibly broken up into discrete interfaces. The rough recommendations at the end of the document suggests a likely way forward. You may find a patch for collections at. So, in itself, collections would be a good addition to PHP. We already have like Laravel collection now, and I think Doctrine collection as well. So there are already good userland implementations. I'm not against PHP having a built-in implementation. That would be useful, especially if it has a object-oriented API instead of like the functional API we're forced to use with arrays now. This syntax is really weird, and it's not solving any real issues, I would say. Let's see here. Because we could already do that with this. So yes, it's a couple of lines less code, but it's not about the amount of code you need to write. It's about being able to, you know, do something here without having to specify a dedicated class. That's actually the reason generics are really useful. Well, that's actually the goal of generics, right? To not have to implement concrete classes. And with this, we still have to do. So it's a syntax that looks like generics, but actually you will need to implement a dedicated class sequence or dictionary for every type. So it's not a generic solution, right? So yeah, I mean, as far as I'm concerned, unless I'm missing something obvious, but this actually has nothing to do with generic typing. So, static analysis. Recent years have seen the emergence of static analyzers. Both PHP, Stan, and Psalm support generics via docblock annotations and are frequently used in open source libraries and private projects. True, here's an example of a generic dictionary class when using PHP, Stan, and Psalm, like the templates annotations here, right? So I wonder where this is going, because this, I feel like static analysis is what brings the true value to generic typing. The docblock annotations are named template for historical reasons, but they implement a generics flavor very close to Java's. Generic types are checked at static analysis time and are not visible at runtime. This offers some benefits of generics, such as type safety, with the following drawbacks. Docblocks can be verbose. True, that is like a real drawback. Type checking requires running a separate tool. That's not a drawback, I would say. That's a super cool thing, being able to pull away all the static analysis out of your PHP runtime and have it run in CI and have it run locally in the background, have it run in an IDE. And, you know, that's like the main benefit of static analysis, is that you don't have to run it at runtime, and you don't and it's not included within that same tool. So for me, this is not a drawback. This is the major benefit of using static analysis. Okay, the next thing, generic type information is entirely unavailable at runtime. This is true, and actually, let's see here. I cheat a little bit here. Let's see. Let's type reflector, I think it is. I actually you abuse these docblocks. Let's take a look here. Where's preg? It was property reflector. My bad. So when a property has a docblock like this at var book like so, I actually, for Tempest, I parse that docblock. And I pull out this type because I need it to to define has many relations basically for models. It would be super cool if there is some kind of syntax that exposes this type. It doesn't have to do anything with it, but just exposes the type of the array via reflections instead of having to parse docblocks. Yeah. Generic type information is not enforced at runtime, so if you don't run a static analysis tool in advance, they accomplish nothing, and that's exactly what we want, because here's the thing, generics are mainly a tool that are useful during development, when you're writing the code, and not during runtime. Like I said time and time again here, we don't need runtime type checks because you don't run into type errors when you run a static analyzer. So this, again, in my experience, it's not a drawback. It might be a drawback in the mind of PHP developers who aren't used to using static analysis. But I would say those people, they're not going to use generics anyway. That's not the target audience. So for the developers who want generics, they are already embracing static analyzers today. And they just want better syntax at this point because docblocks can be very verbose. And that's basically it. Because we can do everything and probably more than PHP will ever be able to support at runtime. We can do it today with static analysis. So the only thing that's kind of annoying is like verbose syntax with this template. Anyway, this verbose syntax, right? You have to define docblocks, which is annoying. But apart from that, everything works. I mean, we've been using generics for years now. This is getting interesting. Erased generic type declarations. Seeing the difficulties with implementing reified generics in PHP core, it has been proposed to implement them only syntactically. Yes, please. Leaving the task to type checking to static analyzers. Yes. In this alternative, the PHP syntax would be changed so that type declarations, class declarations, and function declarations accept generic syntax, but the PHP engine would not check them. Perfect. That's what we need. We can call these erased type declarations because the engine will simply ignore them at runtime. This alternative could be implemented in various ways as part of PHP source, as an extension in an autoloader, doesn't matter. Here's what that same dictionary class as above would look like, right? And so this addresses the docblock verbosity issue of static analyzers alternative, but this introduces an inconsistency. Type declarations cause coercion, but erased generic type declarations will not. And here I say, yeah, let's just, like, if you're running in strict mode, right? Type coercion it's not entirely disabled, but like you get errors when you have do type juggling without being very explicit about it. So I don't mind this. Again, I think it comes down to the developers who are using generics, who are using static analyzers, who are used to writing more typed code, more strictly typed code. They don't need this. So it's okay to have a more stricter language if you're running in like type erased mode. Consider the following example. In this scenario, the first call to add will coerce the argument to string, but the second not. Yeah, true. Yeah. So in this case, 1, 2, 3 will be like automatically converted, and in this case not. And that's not a problem. Just add a string cast here if you want it. Actually, I've got PHP stand configured to disallow this unless you have an explicit string cast here. So in languages like Java, which has erased generics on top of a traditional type system, the compiler does type checking, so inconsistencies like the above do not exist. However, in PHP, these are unavoidable. Yeah, if you assume that you're not running a static analyzer, and that brings me back to my point, if you're using generics, you want to use a static analyzer. Another drawback of erased generics is that they are not visible at runtime. This would prevent pattern matching from seeing generic type arguments, for example. This is an important one, actually. Might be like, let's actually write this down. Let's say match. Let's do the list example because, hang on, let's say it like this. But keep in mind, it's not all about. So something like this wouldn't work, basically, right? Something like this probably, but yeah. I don't know how you would write that, but you could also say something like true list instance of something like this. Probably also wouldn't work, my guess. And remember how I did like regex matching over here? Yeah, I would want the generic type to be available via reflection to solve that. So and it might not be the case here either. So, but let's continue to read. Super interesting. I mean, it's great that they are like looking into this. I'm just like dumping my thoughts as well. And I would really like to hear people's opinions in the comments down below as well. So fully erased type declarations. One way to address the inconsistency issue of erased generics is to change all type declarations to be erased. This could be opt-in with a declared statement, like we don't need runtime type checks. Yes. In this alternative, the engine would stop checking types at runtime. In the previous example, both calls to add would have the same behavior. The value is not coerced. It is then up to the user to check types with an analyzer. Great. This is not uncommon in mainstream interpreted languages, as all of JavaScript via TypeScript, Python, and Ruby have fully erased type declarations. Hey, it looks like there might be something to this. Letting users opt in for fully erased typing and generics on a per file basis would be another option to look at and would make working with PHP Stan and SAM generics less verbose. Some additional benefits of this solution include short-term performance improvements due to the lack of type checking at runtime in opted-in code. Yes. The potential for extending the type system with advanced types like non-empty string, list, int, class string, conditional types, and more. However, there would be significant downsides. It's unclear what impact erased types would have on reflection. True. And like, this is important. The type information should still be available via reflection. And that's why I actually, ignored. I propose to use the term runtime ignored, so that the syntax is still parsed and available via reflection, but that just PHP doesn't do anything else with it, right? Instead of just fully erasing it and acting like it doesn't exist. So this is a very important thing, because like so much code that relies on reflection, which is like almost all framework code, would break if if that was the case. So it would make type enforcement depending on a developer actively choosing to run a static analysis tool, and the majority of the ecosystem right now doesn't use one to begin with. True, but it's getting better, I would say. Let's check here, dev ecosystem survey for PHP, static PHP Stan. Let's see here. Okay. So PHP Stan is growing. Code Sniffer is not, but it doesn't matter. SAM is declining, but SAM is not really all that maintained anymore. Is my feeling. But let's also take a look at the Laravel Ecos Dev survey. I don't know what it was called. The State of Laravel survey. And the results of last year. PHP Stan. So that's almost a 6% increase. Yeah, so it's growing. It really is. And for Laravel, it's almost like half of the people are using static analyzers. Okay, next, it effectively creates a third type mode that developers would have to account for, in addition to strict and weak typing today. True, but I don't really care about that. It would not actually resolve the some types are enforced but others question, as anyone who wanted to use generics but not fully erased types would still be left with a partial enforcement. As anyone who wanted to use generics but not fully erased types, yeah, but I think those are really edge cases that we shouldn't have the whole design defined by a couple of outliers. So PHP is currently unique among major scripting languages for having enforced types. That's a benefit and a market advantage we would lose. I mainly think most people say PHP is very weird, so I don't think this is a true marketing advantage, just my opinion. Generic arrays. This blog post discusses generic objects, but what about arrays? And maybe that's what I was talking about. Arrays are copy on write. Modifying them creates a new copy and modifies the copy instead. This makes arrays safe to pass around, as you don't need to worry about other functions modifying them. From a typing perspective, this means that the type of an array is always dependent on its defined by its content, and this type cannot change because modifying an array creates a new one. From a generics perspective, This is a very convenient property as this makes arrays variant. They can have supertypes and subtypes just like any non-generic class. In other words, the following code is type safe. Let's see here. That's weird. Oh, no, because it's B. It's B, yeah, sure. Usually generic containers are invariant because their type placeholders are used in both read and write positions. This is not the case for arrays because they are semantically immutable copy on write. So the natural way to implement generic arrays is just as explained above. Let their content define their type, and this is illustrated by the example above. Yeah, okay, so inference, right? But this is not what we want, I think. This is something you want to prevent this from happening. This does provide type safety because what matters is that types are checked at API boundaries when passing arguments to functions, returning values, updating objects. Yeah, okay. So over here it matters, but when adding it doesn't really matter. A proof of concept has been implemented, but the performance impact is still uncertain. Another issue is that supporting references and or type properties may not be possible. An alternative to fluid arrays is to fix the type at instantiation time. Yeah. However, this alternative is very orthogonal to how arrays are used in PHP code today. It also makes arrays invariant. Yeah, but it's kind of what we want, to be honest. Well, no, this should be possible, I feel. Like, just an array should accept all arrays. To understand why GA is an error, remember the explanation about invariance. Yeah, it's the generic section. G accepts an array, which means it should be able to add an element of any type to it. However, if we pass array into it, the contract is broken through. Therefore, array cannot accept array int. Okay. Invariance would make arrays very difficult to adopt, as a library cannot start type hinting generic arrays without breaking user code. Yes. And users cannot pass generic arrays to libraries until they start using generic arrays type declarations. Yes, but that's only a matter of time, I feel. That's just a somewhat difficult upgrade path, but it would still be a very useful feature. Now, these pitfalls are why it may also be preferable to focus on object-based collections, either with the custom syntax above described as collections or with more complete full generics as are present in most modern languages. However, the two approaches are mutually compatible. True, because like the collections thing isn't really about generics. Conclusion. We hope to have explained in this article what different options are available for the implementation of generic objects, collections, and or related features into PHP. More work is required and ongoing to determine which options are most desirable or even feasible. The next steps are to investigate. Let's see. Further investigate type inference for reified generics. I really think we should let go of reified generics, but if that turns out to be feasible with acceptable trade-offs, that is most likely the best option and would imply building collections on top of them. Determine if erased generics would have any additional drawbacks not noted here. I feel like we're approaching this way too much from reified / runtime generics are superior, which they are not, and I'm repeating myself, but the community, the sub community of PHP that's using generics, they don't care about runtime type checks because there's this. They like generic type checking is way more powerful when done in a static context. We have our IDE, we have our static analyzers, and that's fine. We just need better syntax. Now, determine if fully erased types would have additional drawbacks not noted. That's super important. Further develop an optimal feature set for collections, which would be applicable either in the dedicated syntax or as an application of generics, reified or erased. Investigate the feasibility of using internal data structures in collections other than hashmap. Sure. halt efforts on typed arrays, as our current thoughts are that this is probably not worth doing due to the complexities of how arrays work and the minimal functionality it will bring. Right now, we're focused on gathering feedback specifically related to the questions below to help guide our next steps. Well, let's see here. Leave your thoughts in the comments, by the way. If reified generics turn out to be infeasible, would erased generics be acceptable, or should that continue to be left to user space tooling? I would say yes, acceptable and far superior to reified generics. What generic features are acceptable to leave out to make the implementation more feasible? Don't allow generics over union types. Union generics are slow and we don't care. Don't support in-out variance markers, etc. Yeah, definitely. In-out markers would be cool, but union types probably definitely not needed. But again, this question only matters if we're talking about reified generics. So I don't really care for reified generics to begin with. But if erased generics are included, would that necessitate an official linter to validate them, or continue to leave that to user space tooling? I would say it would be a good if we're talking about marketing, it would be good for PHP if it had its own static analyzer. I don't think that's going to happen unless PHP Stan decides to basically include its code within PHP, which I think would be a bad idea for PHP Stan. Like you're just giving away all the whole project for free, basically. So that like it doesn't really make sense. For right now, even though we don't have an official linter / checker, I'm totally fine with it. Let's go with erased generics, please. Runtime ignored generics. Now, if reified generics turn out to be infeasible, would the dedicated collection syntax shown here be acceptable? No. That's like, let's see here. Where's my we already have this, and I don't see the need for having some kind of weird syntax that doesn't really help solving the issue. So would erase generics now, and we can probably convert them to reified in the future, be an acceptable strategy if it's determined to be feasible? Well, see, as long as people think that reified generics are a better thing, which they aren't, then yeah, sure, yes. But I'm pretty sure that once we have erased generics, it will be fine and all things will be solved. No, that's kind of too close-minded for me. But like, no, I definitely do it. Yeah, but I don't see the need for adding reified generics after we have erased generics, because the community will embrace static analysis tools, and we don't need runtime type checks because like everything's already been checked during static analysis, and our code won't break anyway. So these are wasted checks, basically. So super interesting, I would say. Let's check the Reddit link here as well, and let's just sort on top. I'm just happy to see the foundation working on it. I agree. Let's get this one out. So this is from Levi, who's also like internal developer. The specific form of collection syntax is something I'm against. Yeah, the tokens collection blah 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 are literally baked into the scanner, and this is not extensible at all to generics in general. I'm totally for shipping collections as a usable motivational stepping stone for reified generics, but the syntax is untenable in my opinion. True. I would prefer generics checked on build with an external tool rather than reduce performance. I don't like the PHP docs syntax I would use PHP attributes instead. Yeah. So yeah, a lot more comments here. Go read it if you want to. Leave link in the description. Like, I'm super happy that they're working on this. I don't agree with all the points made in the article, but it's totally fine. Let's see where it goes from here. So leave your thoughts in the comments, leave a like as well, and then I'll see you in the next one. Okay, bye-bye.